In this video, I'm going to go through the test for independence. And what we're going to be testing are two different categories, or they refer to them in statistics as variables. So two different variables that are whether or not they're independent of each other or dependent of each other. So for example, what if we were comparing level of education to income? Are those two things independent or are they dependent? That's what this test would measure. So similar to the goodness of fit test, it uses the chi-squared distribution. And our data is going to be organized into contingency tables. So we've seen that before, contingency tables. Another way of phrasing that is two-way tables. And the two things that we're comparing are these variables that we are interested in, wondering if they're independent and dependent. Okay, so right here we have the null and alternative hypothesis. The two variables are independent. That's the null hypothesis. So the null hypothesis is always the independent, and the alternative is the dependent. But you'll notice I'm being general when I say two variables. I want you to actually state specific for the problem which two variables we're comparing. So if it was level of education income, the null hypothesis would be the level of education and income of an individual are independent or something like that. Okay. All right. Step two, we're going to calculate expected frequency. So this is kind of a math heavy step. And when we get into the problem, it'll kind of make a little bit more sense, but we're going to take each row and each column, we're going to multiply their totals and then divide them by the table total. So it takes a while, which when we get to the test statistic, it's the exact same test statistic we had for the goodness of fit test, but you might remember that takes a while too. So we're going to actually use Google Sheets to complete this, just to kind of give ourselves a little bit of shortening of the work. All right. We are going to need the degrees of freedom. So the degrees of freedom for this test it's a little bit different than it is for the goodness of fit test. So it is the number of columns minus 1 times the number of rows minus 1. So that's the degrees of freedom that we'll be using, and we'll be still calculating the p-value on Google Sheets. So we'll already be there when we're calculating the test statistics. That's kind of handy. Then we'll compare our p-value to alpha and make our conclusion. All right, so let's scroll down and look at an example. So in a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to help with a disabled senior citizen. The program recruits among community college students, four-year college students, and non-students altogether. So these are the two variables we're comparing. The type of volunteer and how much time they spend. So they want to know, the question asks, is the number of hours volunteered independent of the type of volunteer? So at first glance, I kind of think, well, I know college students are busy. So it might be the case that they can't devote as many hours. And when I kind of look at the numbers, I do see that the numbers kind of decrease in the 7 to 9 hour slot for everybody, right? But there's an increase in the 4 to 6 hours for non-students. So it makes me kind of wonder if maybe being a student does somehow impact the time they're able to spend volunteering. Okay, so according to the test for independence, we're going to state our null and alternative hypothesis. And I have a table here that I've provided that we're going to use in step 2. So this is step 2, okay? So we'll come back to that. But step 1, I'm going to state my null and alternative hypothesis. So the null hypothesis then for this problem is the number of hours volunteered. Wow, helps when you put a space. Number of hours volunteered is independent of the type of volunteer. And the alternative would be that they're dependent. So the exact same statement, but dependent. And I'm abbreviating hours. dependent of the type of volunteer. All right, great. There's my null and alternative hypothesis. Okay, so for step 2, we're going to need to calculate the expected frequency, which means I'm going to need row totals and column totals and the table total. So you'll notice that in the example, you're given space to find the row total and the column total. So let's go ahead and do that. So let's total up the first row. So 111 plus 96 plus 48 comes out to 255. And if you'll just trust me, I did go ahead and do the totals ahead of time. So if you want to pause the video and kind of do them yourself and double check, make sure you got them correct, that's fine. I'm actually going to encourage you to pause the video a few times before I continue. But because I'm talking to myself and not a class, you may want to take the opportunity to go ahead and make sure that you are able to keep up with me. So I'll let you know when a good time to pause the video is. Okay, so there's our row totals and our column totals. So to find the expected frequency, we are supposed to do the row total times the column total divided by table total. So there are 3 rows and 3 columns in this example, which means that if I am looking at row 1 and column 1, that would mean that I am looking at the community college student who volunteers for 1 to 3 hours. So the row total would be 255, the column total would be 298, and the table total 839. So I'm going to do 255 times 298, and then divide that by 839. And I get this decimal. And I'm going to go ahead and go to about 3 decimal places. So 9.572, I'm sorry, 90.572 would be the expected value for my first person. Now, I would pause the video and then calculate the expected value for the rest. I'm going to do one more with you just to make sure we understand and follow. But I will fill out the rest, but I want you to try it too on your own. Okay, so to find the community college student who volunteers 4 to 6 hours a week, that means I'm going to still use row 1, which is 255. But this time I'm going to times it by 379, the second column total. And then I'm going to divide that by 839. So that gives me 115.191. And that is the from row 1, column 2. All right. And you keep repeating this process. You'll do row 1, column 3 now. So 255 times 162 divided by 839. And that's going to give you 49.237. So check that. Take your calculator. Go ahead and calculate these. Pause. And then I'll fill these out and you can check your answers. So for a 4-year college student, this is going to be 103.004. This one's 131.001, 55.995. For non-student, we have, oh, I just realized I put 1,000 instead of 103. Let me fix that. 103. Big difference. Okay, for non-student, this is 104.424. 132.808 and 56.768. Okay, so there are my expected values for each category or each item of these categories. Okay. All right. Now, step 3. And step 3 is when we're going to jump into Google Sheets, but I kind of want to state what we would have done by hand if we were going to do it. So we would be calculating the chi-squared test statistic, which means I'm going to sum up the observed minus the expected. So observed, that's all of these up here. That's what we're given. And then what we just calculated here, these are the expected. So those are the O's and these, I'm sorry, E's and these are the O's. All right. So observed minus expected divided by expected, all right? Which means I would be taking each one of these entries. So I'd start with a community college student for 1 to 3 hours at 111. I'd subtract the expected, which is 90.572, square that, and then divide by 90.572. So I would do 111 minus 90.572 squared divided by 90.572 plus, and then I do it again for the next category, the community college student who works 4 to 6 hours of volunteer work. So that'd be 96 hours minus 115.191, the expected, divided by 115.191, and I missed saying squaring it first. So 96 minus 115.191 squared divided by 115 divided by 115.191, and then I'd repeat this for all 9 entries. All right, and as you can see, that's really cumbersome. It's going to take a while. So I'm going to go ahead and jump to Google Sheets. And since we're going to use it anyways, it's go ahead and worth putting in this information here, and I'm going to show you how to do it. So this would be a great time to pause the video and enter the data. I want to mention or note that the way I entered the data is I went by rows. So I went the first row, 111, 96, 48. That was all the community college student information. And then I went to the second row, 96, 133, 61. And then third row, 91, 150, 53. And I did the same for expected, okay? So just kind of, it doesn't really matter as long as we match them up correctly, the observed with the expected. So go ahead and pause the video and do that. But I'm gonna go ahead and calculate all of these. So to do this, I'm going to go and hit the cell right below this. So I'm following the formula. I'm doing observed minus expected. So I'm going to put equals, and then the observed happens to be over here in this entry A3. So I actually just type out A3, and notice it highlights A3 for me, minus the expected, which is B3, and it highlights that for me, and then equals. So I'm going to hit copy. I'm going to copy that, and then I'm going to paste it into the others. So if you just copy and paste, you actually get the rest of them all worked out for you. All right, copy and paste. And then I'm going to square each of these. So I'm going to take C3 and I'm going to square it. So I'm raising it to the 2. Oh, I forgot to put my equal sign. You have to put the equal sign. Notice how it didn't highlight C3 when I did that? So now it highlighted the C3, okay? And then raise to the 2 and enter. And then I'm going to go ahead and copy this. Here, I'll show you that if you like to show the steps. Okay, copy. And then I'm going to paste. And there we go. We've squared all of them. All right. So now I'm going to take all my entries in D3, or the column D, so D3, and I'm going to, oops, I forgot my equals again, equals D3. And I'm going to divide it by the expected, which is in B3. And enter. And then I'm going to copy that and paste it into the rest. And there we go. So we've calculated all 9 of these. And then to find my test statistic, I'm going to sum them up. Okay, so this is going to give me the test statistic. Wow, it helps if you spell statistic, right? All right, so I'm going to add these together. And to do that, I'm just going to highlight them. And then I'm going to come over here and I'm going to hit the little sum symbol and I'm going to select sum. And it questions me. And I said, yes, that's what I want to add. And there it is. That is my test statistic. So 12.99 is my test statistic. So I'm going to go ahead and write that down. Oops. Tilt the screen back so it's easier for me. All right, so this is chi-squared equals 12.99. All right, and just making a note, I got that from Google Sheets. Okay, so I've done step 3. so now I need to find the p-value. That's step 4. So I'm going to go back to Google Sheets here. I'm going to find my p-value, and I'm going to compare it to alpha. All right. Let's do that. Okay. So to find p-value, since this is just like goodness of fit test, we're going to use the chi-squared right tail. All right. So I'm going to come back to this summation symbol, and I'm going to scroll down to statistical. Oops. And I'm going to select the chi-squared distribution right. And it wants the test statistic, which I actually happen to have right above. So I'm just going to select E12 here. In fact, there. See, it does it for me when I just arrowed up. Selected E12 and then comma, and now the degrees of freedom. Okay, so real quick, let's come back here and do the degrees of freedom, since we haven't talked about that. So the degrees of freedom are the number of columns minus 1 times the number of rows minus 1. So there are 3 columns and 3 rows. So that means that the degrees of freedom, oops, is 3 minus 1 times 3 minus 1, or 4. All right. So I'm going to come back to Google Sheets now, and I'm going to go ahead and put 4 in for the degrees of freedom, hit enter, and there's my p-value, 0.0113. All right. So if you need to rewatch that to follow along a little bit slower, that's fine, but I'm going to go ahead and put down my p-value now. So my p-value was 0.0113, and that is smaller, I believe, than alpha. Did they tell me what alpha is? No, they did not. Oops. Which means that I'll go ahead and just assume that alpha is 0.05. But I think it was supposed to have that there. That is silly that it did not get included. I'll make sure to include it in the sheet I give you guys, so it will be there. So alpha is 0.05, which means that we would reject the null. So what does that mean in this problem, to reject the null? Oops. Sorry, that was floating in the middle of the screen. Okay, so reject the null. And that means that we are saying that they are not independent, but they are in fact dependent, okay? Meaning that, yes, the type of volunteer does affect the number of hours, so they're dependent of each other. So for right now, I'm going to go ahead and state dependent, though you should write a sentence saying that the number of hours volunteer is dependent on the type of volunteer.